Hi, in this video we are going to look at another exam question. It appeared in the Contingencies exam, September 2018, the CT5 exam of the Institute of Actuaries. It's question number 5. A 2-year term assurance policy is issued to a life-aged X. Under this policy, an immediate payment, that's important, an immediate payment of 100,000 is made if death occurs in the first year, rising to 150,000 if death occurs in the second year. Okay, we are dealing with a 2-year term assurance policy. We are asked to calculate the expected present value of this policy. They have given us the basis, mortality. They've given us Px is 0.99, Px plus 1 is 0.975. You know what this notation means. You're told the force of mortality can be assumed to be constant over each year of age. That's good. And the force of interest, delta, is 5%. Now I'm going to go through my solution. You can refer to the examiner's report, which appears on the IFOA website, for an alternative approach or their solution. Our answers are the same. The final answers are the same, subject to some rounding. So let's start. We are looking at a 2-year term assurance policy. That's what you see here, issued to a life-aged X. So I have age X here, age X plus 1 and X plus 2. So if this person dies in the first year, he gets 100K. And if he dies here, he gets 150K. That's good. Okay, we're asked to find the expected present value. So let's deal with the case where the person dies in the first year. Let's move it up a bit. Okay, so if he dies in the first year, that's at this point, let's say it's aged X plus T again. He dies here at age X plus T. The expected present value will be, if he's going to die here, he has to live up to here. That's what you see here, TPX. And then he'll be hit by the force of mortality, mu X plus T, and this person dies. And he gets 100K, and we need to bring it back. We need to discount it. So we have e to the power of minus delta t, and we integrate all this with respect to t, t going from 0 to 1. All that's left is for us to plug in the values. I have 100,000 here. This mu x plus t is constant, so I have this mu here. TPX. Okay, TPX, we know we are dealing with constant force, so TPX is e to the power of minus mu t. Therefore, Px is e to the power of minus mu. Again, Px equals e to the power of minus mu. Take logs and plug in a negative. You will get mu equals to minus log of 0.99. And we know delta is 0.05. Good. Now all we need to do is plug in the numbers, carry out the integration. That's what I've said here. Plug in and integrate. The integration is pretty easy. We are trying to integrate e to the power of ax dx. The formula that we have learned before, this will be 1 over a e to the power of ax plus c. That's the formula we're using. Use that, plug in the numbers 0 and 1, the limits, and you will get 975.452. Okay, that's the first part. Now we need to consider the case where the person dies in the second year. So dying here, this is age X plus T now. Okay, this is age X plus T. For him to die here, he has to live up to here. That's TPX. And then the force of mortality will strike, and we have mu X plus T, and this person dies. So that's what you see here. And the amount he's going to get paid is 150,000. And then you have your discount factor, e to the power of minus delta t. Just take note, t takes the values between 1 and 2. So to get the expected present value, just integrate from 1 to 2, this whole thing here with respect to t, taking note that tpx here, okay, for him to live up to here, he has to live from here to here and from here to here. So you have tpx will be px times t minus 1 px plus 1. That's not too difficult. The reason we have to do that is because the probabilities are different for h x to x plus 1 and h x plus 1 to x plus 2. Good. Px we know, they gave us 0.99, and t minus 1 px plus 1, this will be equals to e to the power of minus mu t minus 1. Note, we have to work out the value of mu for h x plus 1 to x plus 2. That can be done quite easily because we are given this value here, px plus 1 is 0.975. So using the same idea that tpx is e to the power of minus mu t, we can get mu equals to the negative of log 0.975. And delta remains the same at 0.05. Now all we need to do is plug in all the details. You'll get your expected present value. Integrating from 1 to 2, 0.99, e to the power of minus mu t minus 1, mu 150,000, e to the power of minus delta t. Okay, just note that mu here is negative of log 0.975. Do the integration, you will get the expected present value as 3444.97. Again, 3444.97. All we need to do is, to get the final answer, add the two numbers up, this and this, add them up, and you will get 4420.442, and we leave our answer as 4420, and we are done.